All right, welcome everybody. This is TSI Math Crash Course Day 3, Part 1. We're going to be learning today, one of the most important, one of the most effective strategies for TSI Math that is going to simplify essentially any algebra question that you're going to see on this test. So Jackson's joining me today. Again, I would love it, Jackson, if you could read for me rule number 3 on my rules for TSI Math. Loud and proud, please, buddy. Rule 3.
Okay. Avoid algebra whenever possible.
Okay, keep reading.
For variables and solve.
Yeah, good. Notice I didn't say don't do algebra, because if you know how to solve something algebraically, and you feel really confident about it, you can go ahead and do that. Rarely do you need to. But whenever possible, I really recommend trying to plug in some values in place of the variables and then finding the right answer choice based on that. Now, there's a little art to finding the right kind of variables, and sometimes the question limits what kind of variables work, which ones don't work. We're going to talk about all that today, but in general, that's the strategy. We don't want you to think in algebraic terms, don't want you to think in terms of variables. I want you to think in terms of making these questions with variables concrete by plugging in real values. Okay? So go ahead and read question number 1 for us, please, loud and proud.
Okay, which of the following expressions is 5 times as much as the sum of R and S?
Okay. Which of the following expressions is 5 times as much as the sum of R and S? Okay. The part of the question that bothers me is this part right here, the sum of R and S. And, because I don't know what that means. I know sum means adding, but like, the sum of R and S, okay. I guess it's R plus S, but what does that look like? I don't want to deal with variables here. I want to deal with actual numbers. I want to assign some values to these variables. Does that make sense?
Yes.
Okay. So let's do this. Let's make R, and you've got some options here, but we'll make R equal 2, make S equal 3. Okay? It's like kind of funky S. Looks like a 5. I assure you that's an S. Woo, right there. Okay. So let's talk about that now. That's a little bit easier. So if I said, which of the following expressions is 5 times as much as the sum of 2 and 3? Well, what's the sum of 2 and 3?
5.
5. And what would be 5 times that much?
25.
25, right? So when R is 2 and S is 3, we get a value of 25. Does that make sense?
Yes.
All we got to do now, man, is take these values for R and S, plug them into the answer choices, and the correct answer choice will give us 25. Has to. Does that make sense?
Yes.
Okay, great. So let's do it. Let's plug those values into answer choice A. Go ahead and do that, and let's see what we get. You can work that out on the whiteboard for me.
Nice. Where do I get to, the whiteboard?
And anywhere. Did I send you you have a link for the whiteboard?
Yeah, I'm pulling it up right now.
And just find a blank spot anywhere near the problem.
Okay. I'm on the whiteboard.
All right. And then let's see if that expression in answer choice A gives us 25.
Okay, so that would equal 25.
Well, what's 5 times 2?
5 times 2 is 10. Oh, plus 3.
5 times 2 is 10. Right? And this is where you got to think in terms of order of operations a little bit. Have you heard of PEMDAS before?
Yes.
PEMDAS is parentheses, exponents, multiplication, division, addition, subtraction, right? So I don't see any parentheses here or exponents, so we jump right to the multiplication and do that first. So we multiply that 5 and that 2, we get 10. Then we add the 3. Does that make sense?
Yes.
So that's 13. Okay. Questions about that or no?
No.
Okay. Another way, yeah. So that's good. So it's not answer choice A, because I know the correct answer choice has to give us 25. So let's try answer choice B.
Okay.
Again, just plug it in those values in place of R and S. Beautiful. Perfect.
I mean, not S, 3.
Yep. Yeah, there's an undo button
Oh, yeah.
right below the arrow, right above the palette. Yeah, that works pretty well.
All right, so then it would just be 7 plus 3 is 10, so it'd just be 10.
Yeah, that's 10, right? And it's not 25. So there's no way it's answer choice A. Or B, sorry. A or B, for that matter. All right, try answer choice C. I'll clear some space here on the whiteboard for you.
Okay. Okay. So in this one, we would still do PEMDAS.
Exactly.
So we would multiply 3 times 5 first.
Exactly. Yep.
So it ended up being 17.
17. That's 17. Yep. So answer choice C is gone. So far we've eliminated A, B, and C. D is looking pretty good, I hope. Plug it in. Let's see what happens.
Okay.
Yes. I'm glad you drew the parentheses, right? Because now we got parentheses. We have to do the parentheses first. Yep.
And then 2 plus 3, that's 5. And then we drop the parentheses, and we have 5 times 5 is 25.
There you go. Answer choice D. Does that make sense?
Yes.
Okay. Okay. Would that have been clear? Do you think you'd have been able to handle that one without plugging the values in place of the variables?
I don't know, because I might have gone for A.
A looks really good, yeah. But of course, even doing that, if you don't have the order of operations right, you'd still go for A, right? So you do have to have your arithmetic down. There's no way around it.
Yeah.
Right? You got to know PEMDAS. You got to know your order of operations. I'll probably put PEMDAS. I don't have it on the basic concept cheat sheet at the moment, but I'll probably add that onto the basic concept cheat sheet just because that's so darn helpful, that PEMDAS. And I will do that for you. Okay? Just make sure you follow that. Okay. Any questions about question number 1?
No.
All right. Let's do the next one. And then pretty much all day today, in this whole class, we're going to be just practicing this one strategy. Go ahead and read question number 9 for me, please.
Okay. Which of the following values of x satisfies the equation above?
Okay. Now, there's a way to solve this algebraically. You know, I can set the right side of the equation equal to 0, and then I can factor that expression. I don't know if did that make any sense what I just said when I said solve it algebraically or no?
Yeah.
Okay, yeah. Some students might be tempted to do it. There's just a much easier way to do it. And that's just plug in the values, man. Like, we know x is either going to be, it's going to be one of these 4 choices here. It's going to be 7, 3, -2, or -7. So all I got to do is just plug those into the equation and see which of those answer choices gives me a true statement. Does that make sense?
Yeah.
Yeah, that's it. Like, no fancy, we're turning this into arithmetic. Does that make sense?
Yes.
Not doing any factoring, not isolating any variables, just doing arithmetic. All right, so let's do that. Let's just start through, and you might be tempted to start with like C or D or something like that. Like, don't worry about that, right? Let's just go through, because again, if we're doing this the right way, we've got unlimited time on the TSI. We want to cycle through all the answer choices to eliminate the wrong ones and confirm the right one, and then you can be really, really confident in your answer. So let's just start with A and work our way down.
Okay. So we have 7 squared plus 5 7 minus 9 equals 5.
Okay, let's stop for a minute. I don't even want to carry out the calculations here. I'm just looking at this thing. Is there any way that left side of the equation is going to be 5?
No.
Dude, no way. I don't know what it is. I mean, I know like 7 squared, that's 49, and then 7 times 5 is 35. But like, that's a big number. It was like more than like 70, I think, or 60. I don't know. But it's not 5. Does that make sense?
Yes.
Good enough for me, right? And that's the beauty of combining, the basic logic thing and using basic estimation along with plugging in values, is that you don't even have to calculate what it is. You just have to know enough to know that whether it's potentially a correct answer choice or incorrect. And A is just too big. So try that 3. Plug that in and see what happens.
Okay.
So A's gone.
3 squared plus 5, 3 minus 9 equals 5.
Okay. Let's calculate. Can we simplify that a little bit?
So it'd be like 11? No, 12?
This is not 3 squared is 9, and then 5 times 3 is 15, minus 9, so it's actually 15.
Oh yeah.
Right, because the 9 minus 9 is going to be 0. We're left with the 15. We'll essentially cancel out. But regardless, it's not the right answer choice. That doesn't work. Okay? Does that make sense?
Yeah.
All right, B is gone. Let's try answer choice C. Do the same thing, but if you can simplify it this time, don't do the math in your head. Again, you got unlimited time on the TSI. Go ahead and write it all out. You know.
No.
Good. Good. I like that you put those parentheses in there, right? So it doesn't look like 5 minus 2. It's 5 times negative 2.
It's going to be on after 2 hours.
Okay.
There's one more thing, though, too. I would add some parentheses here. Okay? Because there's a difference between negative 2 squared and, in parentheses, negative 2 squared. These are not equal. Did you know that, Jackson? Those are not equal. This means 4. That's 2 squared is 4, so that's gonna be negative 4. That's a negative 4, right there.
Oh.
And then
That would be positive 4.
and then the right hand side is positive 4. Does that make sense? Because negative 2 times negative 2 is yeah. If the minus sign is outside the parentheses, or if there's no parentheses there, that means negative. That means 2 squared, but it's negative. That's what that means. 2 squared is 4, so it's negative 4. But here it's negative 2 times negative 2, which is positive 4. Does that make sense?
Yeah.
Okay. All right. Just be aware of that. Again, you got this is just arithmetic here, but you got to have your arithmetic down to use this strategy. Okay. So let's simplify that. What does that equal?
Okay, so positive 4 plus 5, that's 9. 9 times negative 2 equals...
Well, hold on. We still got to do PEMDAS here, right? Because that 5 right here is being multiplied by the negative 2.
Okay.
So remember, I mean, in PEMDAS, addition and subtraction are last. So let's do we got parentheses and exponents here, and let's do our multiplication exactly. Yep, exactly. Does that make sense?
Yes.
Okay.
Parentheses, exponents, multiplication.
Yep.
Division, addition, subtraction.
Exactly.
So.
Yep.
I will just do this.
Yeah. And I don't think we even have to calculate that. Is that going to give us 5? What's 4 minus 10? This right here, notice you see you've got an addition and a subtraction sign.
Yeah.
If you're adding a negative, what does that mean?
So 4 minus 10 is going to be 6.
What's that?
6.
4 minus 10 is not 6.
I mean, like, negative 4 plus, I don't know why I said that. No, 4 minus 10 would be negative 6. Right?
Negative 6, yep, negative 6. And then minus 9 is going to be even more negative. It's not going to be 5. I think it's negative 15.
Yeah.
Does that make sense?
I'm going to go clean the hot towel.
Does that make sense, Jackson?
Yes.
Yeah? Okay, good. So we can get rid of C. Woo, gone. I sure hope it's D. Boy. Let's plug in that negative 7 for X and see what happens. Yeah, make sure that negative 7 is in parentheses. You can really never have too many parentheses, I've found. Especially when you're plugging stuff in. Okay. Good.
Okay.
This is looking promising.
So first we're going to do parentheses. So 5 times negative 7. 5 times 7 is 35, so it's going to be negative 35.
Yep.
Exponents.
Yep,
So we
you
have
got it.
negative 7 times 7 equals positive 49.
Yep. Yeah. Negative 7 times negative 7. Right. Yep. So negative times negative is positive.
Okay, so now we're going to so we're gonna have 14.
Yeah, that's 14. Yeah.
9.
Yep. And what's 14 minus 9?
5.
Bingo. You got a true statement. Answer choice. Oops. Answer choice D. We've eliminated A, B, and C, and we've confirmed it is indeed answer choice D. You feel pretty confident about that answer choice, D?
Yeah.
Yeah, you should. You get that one right. No question. No question. Any questions about that?
Not really.
Jackson, how much algebra did we do there?
Not very much.
Not
we
any.
Just plugged in our not any.
Not any. I mean, like we just did arithmetic. I mean, we don't have one variable in all of your work.
Yeah. Okay.
This is arithmetic, man. Like grade school arithmetic. Does that make sense?
Yes.
We did 0 algebras. There's really very few questions on the TSI. Same thing for the SAT, for that matter, if you have taken the SAT at some point. It's just very few questions that use this strategy where you really need to carry out a specific algebraic operation. Very, very few. And here clearly you don't need to. Let's do some more. This one looks kind of scary. But it's not. You want to read it for me, please?
Okay, if the square root of 5 minus x equals 4, then x equals...
Okay. The temptation here is, again, to carry out a specific operation, maybe isolate x. I think I could do it algebraically, but boy, I mean, there's a really easy way to do this. Really easy way to do this. How could we solve this simply?
So plug in all the variants, like the A, B, and C, and D.
Yeah, just plug in all the answer choices and see which one gives us 4 on the left-hand side of the equation. Does that make sense?
Yes.
Great. Let's do it.
All right. Okay, so... do plus 21.
Yep, 5 minus negative 20 is 5 plus 21. Yep. Which is... Now be careful that... Now here, I'm going to stop for just a second. Not a major deal here, but this equal sign, right, is inside the square root sign, and I wouldn't do that. I would make it real clear that it ends at... yeah, there you go. Exactly. Does that make sense?
Yes.
Yeah, be real careful, because if that goes over into a part where it's not supposed to be over, you're going to come up with a different calculation. Okay. All right, so 5 plus 21 is what?
5 plus 21 is 26.
26, and is the square root of 26, is it equal 4?
No.
Nope, no way. No. So, I don't know what it is. It's some, like, decimal that would go on for, like, infinity. It's an irrational number. But it's not 4, so it's gone. Lovely. Let's try answer choice B. I'll clear some space. And plug in answer choice B. Yep. 5 minus negative 11 turn it to a positive.
Yeah, and I put that equal sign there, and I'll just erase it.
Okay.
Okay, so 5 plus 11 is 16, and the square root of 16 is 4.
That looks pretty good. That looks really good. It works.
Yeah.
I feel pretty confident, maybe even stopping there.
Yeah, I don't think any other answers.
I mean, let's do it mentally. I mean, look at answer choice C. What would that give us? What would that give us on the left-hand side?
That'd be 6 equals...
No. 5 minus 1?
5 minus 1. 5 minus 1. So that'd be 4 equals 4.
Well, the square root of 4.
Oh, the square root of 4 equals
Right.
4. So 2 equals 4.
Yeah, which isn't true. Right, that's crazy.
No.
So 1's not going to work. What about answer choice D?
11 minus 5.
Or 5 minus 11, right?
Yeah. So would that'd be -6?
Yeah, -6. And you can't take a square root of a negative number.
No.
Because there's no number multiplied by itself is going to give you -6. So you wouldn't have it even a real. That's just nuts. That's not going to work. So yeah, we just confirmed it. It is answer choice B. How easy is that?
It's pretty easy.
Yeah, I mean, if you can do the arithmetic there, you got to keep your negatives straight and all that. But if you know what a square root is, just kind of in general, that's really pretty straightforward. Let me explain real quick for anybody watching the video again how square roots work. Square root just means like there's some number, like we said, the square root of 16. There's some number multiplied by itself gives you 16, and that number is 4. Same thing with square root of 9. There's some number multiplied by itself gives you 9, and that number is 3. Some number multiplied by itself gives you 4. It's a square root of 4, and that number is 2. Okay. Square roots. That's all there is to it. Jackson, you are rocking and rolling.
Thanks.
Yeah, this is good. Let's do a little bit more. Aha, this one's interesting. Question number 11. Go ahead and read this, please.
Okay. If x minus 1 over x equals 20, then x equals a negative 21, b negative 19, and c negative 1 over
Yeah, that's good
19,
enough. Yeah,
and
we're
d.
good.
Yeah.
Yeah, all that. All right.
Yeah.
How are we going to solve this? You can tell me right now.
Plug it in. Plug all the answer choices.
Plug the answer choices. Absolutely. All right, so we'll start with answer choice A. Why do you work to the right-hand side of the question? Just so there's a little more space there. Great. So I'm plugging answer choice A, negative 21. Okay, looking good. Well, now we don't need to leave an x in there, right? We know what x is.
Oh yeah, I didn't mean to do that.
Yeah. Now you're just kind of copying. Good. Okay. Okay. This looks a little bit scary here, but stop and think about it for a minute. We've got negative 21 minus 1 over negative 21. Is there any way that's going to be 20?
No.
No way. No way. It's going to be close to 1. I don't know what the answer is, but it's like anything divided by itself is 1. That's like negative 22 divided by negative 21. I don't know what it is, but it's going to be close to 1. There's no way it's going to be 20. Does that make sense?
Yeah.
Yeah. So I think we can just kind of logically, again, using those estimation skills, so handy, get rid of answer choice A. Okay. Let's do the same thing. Let's plug in negative 19. If you want to just erase and plug in negative 19 instead of negative 21, that's fine.
Okay.
Great. Negative 19. Let's do the same thing here. Is that going to be 20?
20 on top, negative 20 on top, but no.
Yeah, negative 19 on the bottom. Again, that's going to be close to 1. I don't know what it is, but it's not going to be. There's no way it's going to be 20. Like, maybe 400 divided by 20 is 20, but like not negative, 20 divided by negative. No, that's not. The number on the top is not big enough if we're divided by negative 20. So B's gone. So it's either C or D. Eek. Okay, well, let's plug them in and see if we can figure this out logically. Go ahead and plug them in.
Okay.
Okay. Let's stop for a minute because I don't want to have to get all fancy with fractions here. I don't want to have to. Okay? I may show you later. But could that be 20? Let me ask you another question. Is that going to be positive or negative?
I'm not sure how to do
on the
this.
left-hand side. Well, is this going to be, let's talk about the numerator. Is that going to be positive or negative up there?
Positive?
It's going to be, no. If you got a negative, yeah.
Negative, yeah.
Right, you got something negative, and then you make it even more negative by subtracting from it. It's going to be negative. Does that make sense?
Yes.
Okay, and then, of course, in the denominator, that's already negative. So you've got a negative divided by negative. Is that negative or is that positive?
It's still negative, right?
If you got negative 1 divided by negative 1, what's anything divided by itself?
1.
1. Positive.
So it'd be positive.
It's positive. Yep. Yeah. A negative divided by negative, just like a negative times a negative, is positive. Okay. So I don't know what that thing, the value of that left-hand side of that equation is. I don't know. But I know it's positive, and it might be 20. Let's leave it for now. I want to test answer choice D. Okay. So plug in answer choice D.
Okay. All right.
Okay. Let's look at the numerator. Is that going to be positive or negative?
It's going to be positive.
So we've got 1 over 21 minus 1.
Wait, no, that would be negative.
Yeah, this is a really small number. I mean, it's a tiny little fraction. Tiny. And not like negative 1 is really has a lot of value to. I mean, it's just, but it's got a bigger absolute value than 1 over 21. Does that make sense why the numerator is going to be negative?
Yes.
Is it really, okay, you're not just saying that, it actually makes sense?
Yes.
Yeah, okay. Okay, good. Good. Okay, so we know that's going to be negative in the numerator. It's be negative. What about, and the denominator is positive. Down here. We've got a negative divided by a positive. Is that going to be positive or negative?
It's going to be a negative.
It's going to be negative. So it can't be 20. Does that make sense?
If this isn't 20, then what answer is then?
Well, C could be 20. And I think it is. If we plug in C for X. Right? Didn't we determine that when we plugged in answer choice C, we had a negative in the numerator and a negative in the denominator?
Yes.
So it could be 20. But with answer choice D, we get a negative in the numerator but a positive in the denominator. So it can't be 20. Because it's going to be negative. It might be negative 20, I don't know. But it's not going to be 20. Because it's going to be a negative answer for D.
Yeah.
Does that make sense?
Yeah, I guess.
So
it's kind of confusing, but
yeah, like we haven't confirmed C yet. We just eliminated all the incorrect ones. I'm gonna confirm C. I'm going to show you the math with the fractions here just a moment. What are you confused about right now?
just the fractions.
Yeah. Yeah.
That just kind of confusing looking.
Yeah, don't be too intimidated by them. I mean, like right now, all I gotta do, just look at 1 over 21 and be like, that's a really small value. Right? I mean, that's like not much. Like, make it concrete. 1 out of 21 kids in a class.
Okay.
Or like, one red marble out of 21 marbles. It's a really small number. Just a really small part. And at least 1 is a whole number. 1's all like the whole class. Right? Or the whole set of marbles. Does that make sense?
Mm-hmm.
Okay. Let's talk about the fractions. We'll go over the math real quick. I'm going to plug in, and I'll take care of this. I'm going to plug in that negative 1 over 19 because I don't have the answer key in front of me. I'll be honest, and I'm pretty comfortable now that we eliminated A, B, and D that C's the right, but I'm going to try to confirm it here. So I'm going to plug in negative 1 over 19. minus 1 divided by negative 1 over 19. And we'll see if that equals 20. Okay, does that make sense? I mean, I'm just plugging it in just like you did. Okay. Does that make sense now, by the way, why we know that's going to be positive on the left-hand side? Does that make sense or no?
I guess because like you see like 1 over negative 1 over 19. Because you have 2 of those, it would become a positive, right?
The values don't matter. Like it doesn't matter. What matters in this one is that the top, the numerator, is negative, and the bottom is negative. So I know it's going to be positive.
Yeah, that's what I was saying.
Okay, yeah, that's all that matters. Let me show you why I think it's going to be 20. So I can rewrite. I'm going to rewrite this negative 1 over 19 minus. I'm going to rewrite 1 as 19 over 19. Okay, because what's anything divided by itself?
1.
1, right? Absolutely. So, and that's divided by negative 1 over 19. Then, let me simplify this. So when we're adding or subtracting fractions, remember we just, as long as we got a common denominator, which we have here, we got 19 in both denominators, all you do is just add the numerators together. And what's negative 1 minus 19?
Negative 1 minus 19?
Yeah.
Negative 1 minus 19 equals negative 18.
That would be negative 19 plus 1.
No, that would... I don't know. No, I do know, but...
So that would be, I think in terms of a number line.
Negative 1 minus 19.
Yeah, so you ever worked with a number line before? Like we've got 0 and then negative 1, negative 2. Go ahead.
18?
Nothing.
No, so we're taking negative 19 and we're making it even more negative because we're adding a negative 1. It's going to be even more negative. So it's actually...
actually like 19.
Oh, I'm sorry. Yeah. So negative 1 minus 19
equals 20.
Is negative 20. It's a negative 20. Does that make sense?
Yes.
Okay.
That makes sense.
Okay. So that's a negative 20 in the numerator and then still 19 in the denominator. And then we're dividing that still by negative 1 over 19. Does that make sense so far? I've just combined those fractions right here. That make sense?
Yes.
Okay. If you don't fully understand how to add and subtract and multiply and divide by fractions, don't freak out about it. It's not it's helpful, but it's not real essential. Again, we could, just knowing how negatives work, we could kind of figure out what the right answer choice was. But if it's helpful, then to learn the operation in practice, then I recommend it. Okay. So now I've got a fraction being divided by another fraction. I got this fraction here in the numerator being divided by this fraction here in the denominator. Okay. Do you know how to divide by fractions?
I think so.
What's the operation?
I need to refresh.
Yeah. You've done it before at some point.
Yeah.
Here's what you do is you multiply by the reciprocal.
Okay, yeah, I remember.
Right? So we're dividing by negative 1 over 19, so we multiply by the reciprocal of negative 1 over 19. The reciprocal means you flip the numerator and the denominator. So the reciprocal of negative 1 over 19 is, we're multiplied by negative 19 over 1. That's the reciprocal of 1 over 19. Negative 1 over 19. Does that make sense?
Yes.
Yes. Okay. All right, so we're super close. Look, we've got a 19 in the numerator and a 19 in the denominator, and we're multiplying these two values. What can I do?
X them out.
I can cancel them out. Absolutely, man. X them out. They're gone. Cancel that, right? Because 19 divided by 19 is just 1, so it essentially disappears.
All right, so then you have 1 over 1, right?
And then I've got, this is negative, this is 1 over 1, but negative 1 over 1, right?
Yeah.
Yeah, and this is negative 20 over 1. And 1 over 1 is just 1. So I've got negative 20 times negative 1. And what's that?
20.
20. Bingo.
Okay.
And that way we can confirm it was answer choice C. That is complicated. Right? Doing the actual calculation.
Yes.
That's complicated. But again, you can kind of figure it out using some basic logic there. There's an algebraic way to do it too, but that's super complicated. That's even more complicated than this, or at least as complicated. And the algebra just throws students off so much. I just strongly recommend, if you can turn it into arithmetic like you can here, just do that. But at the very least, it's really easy to eliminate A and B. Can we agree on that? It's really easy to eliminate A and B.
Yes.
Yeah. So if you got to guess between C and D, because you couldn't eliminate one of them, you got a 50-50 shot on those. That's pretty good odds. I'll take that. There's worse than 50-50 odds, like 1 in 4, right? Or leaving it blank. I'll take that. Okay. But again, no algebra necessary there. Let's do a word problem. Go ahead and read this for me, please.
Right, the amount of money M in dollars Paul earns can be represented by the equation M equals 12.5H plus 11, where H is the number of hours Paul works. Which of the following is the best interpretation of the number 11 in the equation?
Okay. All right. Okay. Let's do this. I'm going to underline the last sentence in the question here. Which of the following is the best interpretation of the number 11 in the equation? Okay. The thing they're asking us to solve for it, and this is true for, well, every question, but including word problems. The thing they're asking us to solve for is always in the last sentence of the question. Okay, so in a word problem where they've got a couple sentences going on or a paragraph, I like underlining the last sentence. What are we solving for here, Jackson?
The amount of money Paul earns an hour?
Nope. Well, I mean, that might be the right answer. I don't know. But I mean, what are they asking us to solve for?
What's the best interpretation of the number 11?
Yeah, what's the number 11 mean in that equation? Okay. What's the number 11 mean? Okay. Now, one thing to do is maybe just take a look at the equation, just kind of stare at it, and then hopefully pray to God that the correct answer slaps you in the face. But it's just not obvious looking at an equation what things mean. I don't think it's obvious for most students.
It's not obvious for me.
Yeah, it's not obvious. It's not obvious. It's not obvious for me right now either. Think I know. I might be able to figure it out. But we can make it really obvious by plugging in values for H. Okay? And again, let's make this concrete. We're not just plugging values for H. We're going to test numbers of hours that Paul is working. Let's do that. Does that make sense?
Yes.
Okay. So let's plug in a 1 for H. We'll make H equal 1. It means Paul's working 1 hour. Okay? And then M is the amount of money he makes. Right? So we're about to find out how much money he makes after 1 hour. So what's M equal when H is 1?
M when H is 1.
Mm-hmm. Yeah. How do we find that out? Do you know?
Well, it's 12.5. I don't know.
Yeah, it's 12.5 times H, right? That's what 12.5 H means. And like we said, H is 1. We just made it 1 up here, but we're testing that value. So we're just going to plug it into the equation. 12.5 times, not times H, times 1, plus 11. Okay? Does it make sense what I did there in that equation?
Yes.
Okay, there was an H, now there's a 1. Because I set H as 1.
You just changed the value of H.
Yeah, or I just created a value. Because at the moment, up here in the equation, it's just a variable. It could be anything, any number of hours. Right? And I said, let's see what happens after he works 1 hour. Does that make sense?
Mm-hmm.
Okay. So this is going to tell us, and again, M means the amount of money he's made. This is going to tell us how much money he made after working 1 hour. How much money did he make after working 1 hour? Oh, it's not plus 1, it's plus 11. Sorry. There we go. How much money did he make after working 1 hour?
So $21.
So it's 12.5 times 1, which is 12.5, right? 12.5
plus 11.
Plus 11. You can add that on your calculator if you want to.
So 23.
Yeah, I mean, you're rounding it.
23.5.
Yeah, let's try to be more specific. I would say 23.5. 23.5. 23.5. Okay? Does that make sense?
Yes.
Okay. So again, let's make this concrete. This means after Paul's worked 1 hour, he's made $23.5. $23.50. Does that make sense?
Yeah.
Okay, great. Let's try another value. Let's make h equal 2. Let's see what happens to m after he's worked 2 hours. So we'll plug it back in, 12.5. But now it's not times h or times 1, it's times 2. Plus 11. Does that make sense?
Mm-hmm. So now we just do 12.5 times 2.
Yeah, go and carry. Yeah, you can just punch that into your calculator and see what we get here.
So 25 plus 11 is 36.
36. Interesting. He's made $36 now. How much more did he make after working the extra hour, between 1 and 2 hours? Can you calculate the difference?
Yeah. So it's going to be $12.50. So
yeah,
that's how much.
That's the difference, right, between after working 1 hour and working 2 hours.
So there's going to be that much increase in every hour, I guess?
That's what it looks like, right? I mean, we can test it with 3. Do you want to plug in a 3 for h?
Yeah.
Let's do it. So when h is 3, m equals, it's 12.5 times 3 plus 11. Now you're thinking the right terms. What's that?
So 37.5 plus 11. That's $48.50. $48.50.
That's after working 3 hours. What's the difference between 2 and 3 hours?
What did we say the difference was between 1 and 2?
Between 1 and 2, $12.50.
$12.50. So 36 plus 12 equals 40.
Yeah.
48.50. Yeah.
Yeah. So $12. Yeah. Great. Okay.
That's it.
So every hour he's making $12.50 more.
Yeah.
Does that make sense?
So he's making $12.50 an hour.
Yeah. So what's up with the 11 though? Right, looks like we're adding that to what he's making per hour. It doesn't change. I tell you what, let's look at the answer choices. I'll bet we can eliminate some obviously incorrect answer choices right now. Does that make sense?
Okay.
Go to read answer choice A.
The amount of money in dollars Paul earns each hour.
Okay. Is 11 the amount of money he earns each hour?
It's 11?
Well, that's my question. Is that 11? Is that the amount of... No. Right? We already established. How much is...
$12.50.
What's that?
We see that as $12.50.
Yeah, we calculated that easily, right? It's not 11, it's $12.50. So A's gone. Does that make sense? Really easily. He's making $12.50 an hour. We already figured it out. We calculated. We went from 1 to 2 to 3 hours and saw what the change was. Okay. Go ahead and read answer choice B.
The total amount of money in dollars Paul earns after working for 8 hours. I don't think that's it.
No. We already know with the total. I mean, if he works 1 hour, he makes $23.50. Not $11, right?
Okay.
So there's no way it's going to be answer choice B. Does that make sense?
Yes, that makes sense.
Okay. Go to read C.
The total amount of money in dollars Paul earns after working for 1 hour.
Is that what 11 represents in the equation?
I don't think so.
No, because how much does he made after he worked 1 hour?
$12.50.
Yeah, each hour he's
$23.50.
Right, $23.50.
But we see. Wait. Okay, yeah.
Every hour he makes $12.50 more. Right.
Yeah.
But
so D makes sense because it says in its addition. It's in addition to an hourly wage.
Okay. Yeah, the amount of money in dollars Paul earns in addition to an hourly wage. So it's like a flat rate. It's like it charges you, it'll cost you $11 for me to come out, and then $12.50 for every hour that I'm there doing a job.
Okay, yeah.
Does that make sense?
Yes.
That's what the 11 is. It's like a flat rate, a service fee, something like that. Make sense?
Yes.
And even if D is like, we know it's not A, B, or C. We know it's not.
Do the math. We could have just read that.
Could have just read what?
But answered D, and it would have made sense.
Do you think just by looking at the equation, you would have been able to figure it out?
Maybe after studying it? I don't know.
I find after plugging in the values and seeing what happens, it's really easy. Look, if you just read a question like this and you just know intuitively, you just really know algebra inside out, and you know what things represent in an equation, what everything means, great. I'm down with whatever works. I've just found for the vast majority of students, testing some values and finding out how things change as we change the values always gives insight. Always gives insight. And generally helps you find the exact correct answer.
Yeah.
And because we put in those values, we know with absolute certainty we can eliminate A, B, and C. And D makes sense. Okay?
Okay.
All right. So even though there's they're not asking us what H is or what M is or anything like that, just by kind of playing with things. Look at these questions like an experiment. Not just boy, I hope I interpret it the right way. It's okay, let's see what happens when H is 1, when he's worked 1 hour. Let's see what happens when he's worked 2 hours, how much money he made. Let's see how much money he makes with 3 hours. And you can generally kind of figure it out, right? You're kind of creating your own evidence. Does that make sense?
Yes.
Like you can get more information than they give you in the question. You can create your own information. You can create your own evidence by dealing with real numbers. Okay? That's what we're talking about here. You don't see a ton of word problems like this on the TSI, but they pop up, and that's a useful strategy. Ooh, I'll press the wrong button there. Try that again. All right, let's do this guy here. Then we'll take a little break after this question. If it pops up. Hold on. Come on, buddy. There we go. Great. Question number 5. Go ahead and read this for me, please, Jackson.
Okay. In the xy plane, a line crosses the y-axis at the point 0, 3, and passes through the point 4 and 5. Which of the following is an equation of the line?
Jackson, are you pretty comfortable graphing lines?
Yeah, I would say so.
Okay.
I'm okay at it.
Okay. We got a couple options here. We can plot those 2 points, right? That they give us, 0, 3 and 4, 5. We can plot those on an xy axis, draw the line, right? Because if you got 2 points, you've got a line. And then try to match up the equation of the line with the equations, the answer choices. That's one way to do it. There's another really easy way to do it, which is to plug in values.
Yeah.
We know that for this line in question, when x is 0, we know what the y value has to be. What's the y value have to be?
3.
Yes, 3. It's got to be 3. It's got to be 3. When x is 0, y is 3, right? Because these are called ordered pairs. That's the x value there, that's the y value there. In an ordered pair.
Okay, so then
You've seen that before, right? Right?
That means we eliminate C and D.
Yeah. Absolutely. You're jumping ahead just a little bit. We're gonna get there, but you're thinking in the right terms now. You see where we're going now?
Yes.
Yeah. Okay, great. We also know that when x is 4, what's the y value?
5.
5. Because it tells you we've got another ordered pair here. It's x comma y. So when the x value is 4, the y value is 5. Always for this particular line. Is this making sense?
Yes.
Okay, great. So let's do it. Let's plug in. Let's start with 0, 3. I think that's going to be easy to test. Okay? And let's plug in a 0 for x and a 3 for y into the answer choices and see which one gives us a true statement. And see if we can eliminate any of them. Okay?
Okay.
All right. Let's do it.
So for A?
Yeah.
That we write it like this?
Yeah, but what do we plug it in for y? You don't have to rewrite the equation. Just plug in the 3 for y and a 0 for x. Does that make sense or no?
Don't write the equation?
Well, don't write the y, right? Because I said, remember, y is not 0. The x is 0. For 0, 3, that's the x value. The 3 is the y value. So here's how I'd write it. I'd write it as answer choice A would be 3 equals 1/2 times 0 plus 3. Okay?
That's a true statement.
It is, but does it make sense where I got my zeros and threes came from?
Okay, so what you're doing is you're replacing x with 0.
With 0, yeah. I'm plugging a 0 for x and I'm plugging a 3 for y.
Okay.
Does that make sense?
Yes, that does make sense.
Okay. So A is a true statement. Let's leave it. Okay. Let's plug those values in answer choice B. Let me see you do it. So just plug in a 3 for y, a 0 for x, see what happens. Yep. Good. Okay. Is that a true statement?
So this is true.
Also true, right? Because 2 times 0 is 0, 0 plus 3 is 0. 3 equals 3. That's good. Okay, so I can't eliminate A and B. Try plugging them into, plugging those values into C.
So that's not true.
That is not true, right? Because that's going to be, that part, anything type, sometimes on the erase function, I don't realize I am. That part here is equal to 0, because anything times 0 is 0. So in a sense, it actually does disappear. And you get 3 equals -4, which is crazy. So we don't have to worry about answer choice C. Okay? And then just look at answer choice D.
And it's not right.
Yeah, it's not right. 2 times 0 is 0. 3 does not equal
-4.
It's the same thing as C, essentially, so answer choice D is gone. Right? And I think visually, you just kind of figured that out early on. You're like, wait a second. If I can just plug in those values, it's not going to be C or D. Does that make sense?
Mm-hmm. Yeah.
Okay, great.
It does.
All right, let's do the same thing, but now they've given us 2 sets of points. Let's do the same thing with 4 and 5. Right? Where x is 4 and y is 5. Let's do the same thing. We're plugging those different values. I'm just turning this into arithmetic here.
So does that mean we only are going to do A and B since we are?
Yes, yeah, we don't have to worry about C and D. If it doesn't work for 0, 3, it's not going to work for 4. It doesn't matter if it works for 4 and 5. It's not going to give us a true statement. It's got to be true for both. That's what I meant to say.
All right.
Is that a true statement?
So it'd be 4 over 2. Is that how you would write that?
Yeah, and what's 4? And what's 4 divided by 2?
So 2.
2. What's 2 plus 3?
2 plus 3 is 5. So that's true.
That's a true statement. Yeah. So let's leave A, but plug those values into answer choice B.
All right.
See what we get.
5 again equals 2. 4 plus 3. So 2 times 4 is 8 plus 3, 11.
Yeah. No way.
So no.
No way.
The answer is A.
Yeah, answer is B is gone. It is A. Any questions about that?
No.
Okay. Plug in the values, man.
Mm-hmm.
You don't need to graph it. You can, and let's. I want to do it real quick just to show you how to think in like y equals mx plus b form terms. Again, you just don't need to get fancy. But where would the point 0, 3 be on the number line? Could you find that 0, 3?
0, 3.
Mm-hmm.
So this is 0 right there.
Yeah,
This
x is 0.
1.
Mm-hmm.
This is 2.
But then remember, the 3 is the y value, so it's going to be on the 3 is going to be on the y-axis. Yep, so we're going up 3. Mm-hmm. Yep.
So this is 0, 3 right here.
Yes, right. Show me. Yeah, absolutely. 0, 3. Does that make sense? Right there, the x value is 0 because here's the x-axis, and the y value is 3 because the y-axis goes up and down. So that's 0, 3, and then what's the next point? 4, 5.
So this is 4.
Mm-hmm. Yep.
And 5 would be 3. I mean 4.
4
5.
and then 5. Yep. And then find where those 2 points. Okay, but that's not. Where's the point 4, 5? Yes, there you go. Yep. Yep. There it is right here. So for those of you watching, that's 4, 5 right there. 0, 3. Does it make sense why that's the point 4, 5?
Yes.
Okay, because the x value is 4 and the y value is 5 at that spot. Okay, you got 2 points. You got a line. Woo, something like that.
Intercept.
And then if you know y equals mx plus b form, which you don't really need to know here, there's not a ton of graphing on the TSI. But if you're familiar with that, the b value is the y-intercept. That's where the line hits the y-axis, which of course is 3. Right, that's where it hits the y-axis at this point. And then the slope is the rise over the run. We go up 2 over 4. 1, 2, 3, 4. Up 2 over 4, so the slope is 2 over 4, which is the same as 1/2. Y equals 2 over 4 x plus 3, which is the answer choice A. But I like the first way better. And I think that's probably easy for most students. Whenever they give you like an equation of a line and points on the line, you can generally plug in the points to figure it out. You don't actually have to do the graphing. I think it's easier. Any questions about that?
No.
No? Okay. If that whole graphing part didn't make sense to anybody watching the videos, don't freak out about it. You don't need it for this problem. You just turn everything to arithmetic, which is what we're trying to do here. Simplify this as much as possible. All right, Jackson, let's take us a little 3-minute break. Okay? And then we will continue working on this very powerful strategy. I'll see you in just a couple minutes, okay?
All right.
All right, thanks, Jackson.